Our seventh competitor this evening is Ashton Greer from the Department of Civil, Construction, and Environmental Engineering. The title of Ashton's talk is Combating Climate Change with Computer-Based Design.
This competition, for me, it's just been kind of a way to come out of my shell and my comfort bubble and present my research to people who have never been exposed to it before. The American Society of Civil Engineers issues a report card every 4 years, assigning a letter grade to each of our major categories of infrastructure. In 2013, our overall GPA was a D+. Our infrastructure hasn't always been on the verge of failure, though. The engineers who designed it to meet the standards and conditions of the times during which it was constructed. And for decades, it mostly performed as it should. However, changes in climate and increasing urbanization are causing floods that far exceed the capacity of the flood protection infrastructure designed for historical conditions. The objective of my research is to use geographic information systems, or GIS, to both analyze and design our current and our future water resources infrastructure. A GIS is a software program used to store, view, and analyze spatial data. In the past, it's mainly been used by geographers and engineers who wish to create digitized maps. My research pushes the limits beyond GIS's mapping capabilities by producing a novel method of designing hydraulic infrastructure completely within GIS at a simple click of the button. The first step in designing any piece of hydraulic infrastructure is analyzing land use, elevation, and precipitation data to tell me how much water is going to be flowing into it. After I've determined this peak flow, I can use a rigid set of systematic equations to determine all of the parameters needed to produce a complete design. The programming capabilities within GIS allow me to produce these designs in seconds rather than the hours that it could take to do by hand. This will allow me to perform an analysis on a large data set of existing infrastructure that, prior to the development of my GIS-based tool, would have taken far too long to be feasible. Since climate and land use have changed in the decades since this infrastructure was built, it is my hypothesis that the potentially damage-inducing effects of these results will be evident in my results. The engineers of decades past were designing for the conditions of their times, but we have the ability to move forward. The American Society of Civil Engineers won't release another report card until next year, but it's my hope that we can use these computer-based concepts to help our infrastructure pass whatever test it may face next. Thank you. I think they reacted okay. I was trying to make eye contact with them throughout the whole thing, and they seemed engaged and interested in what I was saying, so hopefully they liked it.